Hi there, Mr. Sutton here with the Pre-Cal Honors 6-1 Part 1 homework solutions on polar coordinates and graphs. For number 1, we want to plot the following three coordinates on the polar axis. So starting with point A, we've got 3, 660. So this 660, to make this a little easier, let's subtract 360 from it to find where it is between 0 and 360. So we could write this as 3, 300. That would be equivalent. So we want to turn in the 300 direction here and go out 3 on the radius for that point. Next, point B, we're going to a radius of 4, and then this means go clockwise 225 degrees. So let's see, here's 180 plus another 45. That brings us to positive 135. And for this one, we want to go to 210, but backwards 2 steps. So we're going to turn in the 210 direction here, but we're going to go backwards this way 2 steps to bring us to 30, 2. So another way of doing these, you could have added 360 to this one, and you could have added 180 or subtracted 180 from this angle to get equivalent angles here. For number 2, we need to graph these three polar coordinates. So for this first one, 1, 600, we'll make this a little bit easier by subtracting 360 to give us 1, 240. So we're going out 1 and over to the 240 ray over here. Next, for B, we're going 60 degrees clockwise, so out 3, and then 60 clockwise brings us to 300. You could have added 360 to that to get the same number. And then for C, so we're going out 4, but instead of going to 300, we want to go backwards on this 300 ray. So we actually want to go out 4 on the 120. Now another way of getting this, you could rewrite this as 4, 120. If you make the radius positive and add or subtract 180 from the angle, you get the same place. For number 3, they want 2 other pairs of polar coordinates that are equivalent to this point. So one way of getting another polar coordinate that matches this one, if you keep the radius the same and either add or subtract 360 to the angle, I'm going to add 360. So 3, whatever negative 100 plus 360 is. So that would be 260. And then another way of getting an equivalent point, you can make the radius negative and either add or subtract 180 to the angle. So I'm going to make this negative 3 and then negative 100 plus 180. So that's negative 3, 80 degrees. For number 4, I want 2 other pairs of coordinates for this point. So one way to do this, we can keep the radius and add or subtract 360 to the angle. So I can write this as 7, 50 plus 360, which is 410. Another way to do it, you could make the radius negative and either add or subtract 180 to the angle. So I could write this as negative 7, 50 plus 180, or 230 degrees. On this problem, we're trying to get 2 other pairs of coordinates for this polar point here. So there's 2 different ways to get polar coordinates that are equivalent to what you have. One is to either add or subtract 360 while keeping the radius the same. So for example, here we could do 3, whatever negative 330 plus 360 is, which would be 3, 30 degrees. Now another way, other than subtracting 360 or adding 360 again, that you can get an equivalent point is if you make the radius the opposite sign from what it already is and add or subtract 180 degrees. So we could call this negative 3, negative 330 plus 180, or negative 3, negative 150 degrees. For this problem, we're trying to get rectangular coordinates based off of this polar coordinate here. So we're going to do an x and a y formula. The x value is just going to be the radius times the cosine of 30, cosine of theta. So we've got 3 cosine of 30 in this case. Now cosine of 30, we know that's root 3 over 2. So this is 3 times root 3 over 2, which we can call 3 root 3 over 2 if we want to just make it look a little bit nicer. So that's going to be the x value of our coordinate. Now for the y value, we need to do y equals r sine of theta. So that's going to be 3 times the sine of 30. Sine of 30 is 1/2. So we have 3 times 1/2, or 3/2, for the y value there. On this problem, we're trying to get rectangular coordinates out of these polar coordinates. So we need an x and a y value. For the x value, that's going to be r times the cosine of theta. So in this case, we've got 3 times cosine of 270. Cosine of 270 is 0. So 3 times 0 then just gives us 0. And that's the x value of our point. Now for the y value, we need to do y equals r sine of theta. So this is going to be 3 times the sine of 270. Sine of 270 is -1, so 3 times -1 is going to give us -3 for the y value. On this problem, we're trying to get rectangular coordinates for these polar coordinates, so we need an x and a y value. X value is going to be r times the cosine of theta, so 4 times the cosine of 300 in this case. Now the cosine of 300, to find this, I'm going to use a reference angle. That's going to be 60 degrees, 360 minus 300. Cosine's positive in quadrant 4, so I can rewrite this as 4 times the cosine of 60, positive all of that. Cosine of 60 is 1/2, so we've got 4 times 1/2, which is going to give us an x value of 2 for our final point. Let's find the y value now. We've got y equals r sine of theta, so that's going to be 4 times the sine of 300. Same reference angle as before, 60 degrees, but sine is negative in quadrant 4, below the x-axis, so I have to rewrite this as -4 sine of 60. Sine of 60 is √3/2. So I can reduce the 4 and the 2 here. This ends up giving me -2 radical 3 for my y value. For number 9, we're given a polar coordinate, and we want to give the rectangular coordinate instead, whether it's exact value or nearest tenth. So for this one, we need an x and a y value based on the r and the angle. So for the x value, that's going to be the radius times the cosine of the angle. So this is -4 times cosine of 60. Cosine of 60 is 1/2. -4 times 1/2 gives us an x value of -2. Now for the y values, that's going to be r times the sine of the angle. So that's -4 times sine of 60, which is, let's see, √3/2. So -4 times that. The 4 and the 2 cancel. That gives us -2 √3. And then putting those together to give the actual point, we've got -2 comma -2 radical 3. For number 10, we're trying to turn these rectangular coordinates into polar coordinates. So we're starting with an r and a theta, trying to get an x and a y. For the x value, that's going to be r times the cosine of theta, so 5 times the cosine of -84 degrees. And I'll do that on the calculator in a sec, but let me speak to the sine issue here, the y issue. So y is going to be r times sine of theta. So then that's going to be 5 times sine of -84 degrees. Let me go ahead now and plug both these in my calculator. So make sure you're in degrees for this. We've got 5 cosine -84 comes out to roughly 0.5 if I round off to the nearest tenth. And then 5 sine of -84 is going to come out to negative, I guess this would be 5.0 if we round that off. So 0.5 comma -5.0 for that one. For number 11, we're turning this polar pair of coordinates into a rectangular pair. So for the x value then, that's going to be r times the cosine of theta. So -3 times cosine of 130, which we'll do on the calculator in a minute. And then for the y value, we need r times the sine of theta. So -3 times sine of 130. Let's go to the calculator for these. Making sure we're in degrees, we've got -3 cosine of 130, which gives us about 1.9 if we're rounding to the nearest tenth. And then -3 sine of 130 is going to be about -2.3. So there is our rectangular pair. For number 12, we're trying to get rectangular coordinates for this polar point. For the x value, that's going to be r times the cosine of theta, so -3 times cosine of 90. We can actually do this without a calculator. Cosine of 90 is 0, so this is just 0 for this. And then for the y value, we need r times the sine of theta, so -3 times sine of 90. Sine of 90 is 1. Negative 3 times 1 is just negative 3. Making sure we actually write a point out of all this, that was the point of this, right? We've got 0, comma, negative 3.